Today's lesson is about displacement. And to understand displacement, we need to use our knowledge of the reactivity series. How it works is a more reactive metal will displace a less reactive metal from its compound. So the example we can look at is iron and copper oxide. So you only pay attention to the metals in the reaction. So iron plus copper oxide, what will happen? So we only pay attention to the metals. So we've got iron and we've got copper. You think back to your reactivity series. You might want to write it down in a list so that you can refer to it throughout this lesson, and we work out which one is more reactive. Iron is more reactive than copper. So iron will displace the copper from its compound. So the iron displaces the copper, so it takes its place and becomes iron oxide, which means the copper is left by itself. Here I've got 3 examples to go through with you. If you are confident about this, you can pause the video now, try and do it yourself, and then I will go through the answers. Okay, so for each example, I need to pay attention to the metal. So I've got lead and I've got copper. The next step is to use my reactivity series to see which one is most reactive. So the lead is higher up in the reactivity series, so that is more reactive. So the lead will displace the copper and join to the bromide, which will leave copper by itself. Question 2. Identify the metals, iron and aluminium. Check the reactivity series to see which one is more reactive. Aluminium is more reactive, so now I know it is going to form aluminium oxide because the iron will be displaced. Example 3, identify the metals. I've got potassium and I've got iron. Check your reactivity series, which one is more reactive. Potassium is most reactive. Will iron displace potassium? No. So all I need to do is write no reaction. Now I'm going to show you a demonstration of displacement reactions. So I have got magnesium sulfate, zinc sulfate, iron sulfate and copper sulfate, and I have already added that into the Petri dishes in the right place. And then one by one I am going to add magnesium, zinc, iron and copper. And the way it works is you look at the top and you look at the side and it tells you what is in that dish. So what we're going to be looking for is evidence as to whether displacement has occurred. So in this first one, I'm going to add magnesium and magnesium sulfate. So again, we're identifying the metals. I've got magnesium and magnesium. Well, they're the same metal, so I'm going to expect that there's going to be no reaction because magnesium is exactly the same reactivity as magnesium. So if I put my piece of magnesium in there, nothing happens. Then I have got zinc and magnesium. So if I put the zinc in there, then I have got some iron filings. Take a scoop of that, put it in there, and I've got a piece of copper and I put it in there. Now because the magnesium is more reactive than zinc, iron and copper, there is no reaction. Now I'm going to move on to this row. So I am reacting zinc sulfate with magnesium. So we can look at our reactivity series. I have got zinc, which is here, and I've got magnesium, which is here. So the magnesium should displace the zinc from the zinc sulfate, and we should see a reaction. What you can see is there are tiny bubbles being released that show me that something is happening inside this Petri dish, which means there is a reaction. Then I'm going to add zinc and zinc sulfate, so it's the same, so we're not expecting anything to happen. I'm going to add a spatula of iron. Iron over here and zinc, so the zinc is more reactive, nothing is happening in the dish, and copper, which is all the way down here, is not more reactive, so there is no evidence of a reaction in the dish. Now we're going to move on to iron sulfate. So magnesium is higher in the reactivity series than iron, so I'm going to put that in and see if there is a reaction. Straight away I can hear fizzing, I can see it moving around because there are bubbles of gas being released. Definitely got a reaction there. Zinc plus the iron. So zinc is higher than the iron, so I would expect there to be a reaction. Might be a little bit slower, so let's move on. So we've got iron plus iron, they're both the same, so nothing will happen. And copper is not more reactive than iron, so again we would expect nothing to happen. Now I'm going to go back to the zinc. I was expecting a reaction to take place because zinc is higher up in the reactivity series than iron, so I have taken the big piece of zinc out and I'm going to add some zinc powder very carefully to see if we can get a reaction there. To give it a bit of a stir. Oh, I can already see. Okay, we've got some bubbles, definitely some gas given off. Magnesium and the copper. We'll leave that to see if there will be a reaction. I'm going to use the zinc powder again because that worked better to see if there is a reaction. Iron. Now iron, this time it's the first time iron has been more reactive than something. So we've got iron up there and copper down here. So we are looking for what this reaction looks like. And then copper plus copper, we're not expecting anything there. So very slowly, if I knock it, you can see the bubbles coming off. So there is a slow reaction with the magnesium, but it's definitely a reaction. There is a large amount of odour being produced from this one, and it is bubbling slowly, but there is definitely a reaction here. Here, the iron is starting to change colour. So there is a colour change which indicates that the reaction has occurred, and copper plus copper, no reaction. What you now need to do is draw yourself a version of this results table. So we have got 1, 2, 3, 4, 5 columns going across, and 1, 2, 3, 4, 5 going down. And what you need to do is record whether there was a reaction or not. So you can go back to look at the video and you would just put in a tick or a cross to show whether there was a reaction.